Let's look at another example where we calculate the capacity of any particular cut in a flow diagram. I think it's important to note though that a cut does not determine how much flow there's actually occurring. What it does calculate though is what is the theoretical capacity at that point or at those set of points in a network. So each of these cuts, for example, so I've drawn 4 cuts here in this network diagram. Each of these cuts will give you a different value in terms of the flow capacity at these points. So cut 1 cuts edge SA and SB, for example. That doesn't actually mean that there's 25 plus 40 units of flow happening at that point. It just means that that is in fact the capacity of those pipes or the roads or lines or whatever at that point in the network. Okay, working out the maximum flow of the entire network is something else. Okay, so all we're doing is we're just calculating again just the capacity of these 4 cuts. Okay, let's have a look at cut number 1. Okay, so cut number 1, okay, cuts off the flow from source to sink, okay, by cutting basically that edge there and that edge there. So clearly you can see that cut number 1 is a valid cut. Okay, I'm just going to draw these back in. Okay, and all we do is we just add the capacities of the edges that are involved in that cut. So 25 plus 40, the value of that cut is 65. Let's have a look at cut number 4. Now notice that I've skipped these 2 cuts in the middle because they take maybe potentially a little bit more time, just a little bit more analysis involved with those. Cut number 4 is another obvious cut that cuts off the source from the sink. Okay, and that one is the capacity of that cut is 30 plus 50, which is 80. So notice that cut 1 and cut 4 will isolate the source from the sink, but they're totally different values. One's 65 and one's 80. So that tells you the capacity of the size of the pipes, but that doesn't actually tell you how much is actually flowing or what the maximum flow is in the entire network. Okay, that's the maximum flow or the minimum cut maximum flow theorem. Okay, what about cut, let's say cut number 2. Okay, so cut number 2 cuts off SB. Okay, so what I might do is I might just remove a little bit of the whiteboard marker ink there. Okay, is there another path to get from source to sink? Yes, there is, through SA and AT and also SA, AB and BT. Okay, so you will need to definitely cut this point here. Yep, so the cut through SB is valid. AB, the cut through there is needed, okay, to cut off the source from the sink, and also this edge here, AT, also needs to be cut. So I'm just removing that. So you can see clearly that by putting in these cuts, okay, you will isolate the source from the sink. There is no flow possible. So what we're calculating is the sum of these pipes, okay, or these edges. Okay, so that'll be 40. Okay, plus 15 is 55, plus 30 is 85. All right, what about cut number 3? Okay, so cut number 3 cuts off SA, okay, cuts AB, and also cuts BT. Now, let's cut SA first. Okay, by cutting off SA, it cuts off the inflow to A, which automatically cuts off the outflows. Okay, so AB is actually not a relevant cut. It's not even, it's an unnecessary cut. You can't include this 15 in the cut. If you're cutting off the input to a vertex on the way to the sink, all the outflows are automatically cut off anyway. So that is not valid. We don't actually include this this edge here, but we do need to include this edge BT, because if we don't, there is a path from source to sink, SB, and then BT. So if I just take a little bit of ink off there, okay, have we cut off the network completely, entirely? Yes, we have. If anything tries to flow from S to A, whoop, stops there. So these edges automatically won't get anything, so the flow will be 0 there. And also through vertex B, SB, well, there's sort of a roadblock there, nothing will get through. Okay, so it's actually just these two that we need to add up. Okay, so it'll be 25 plus 50 is 75. Okay, and so these are the capacities of these four cuts.